Hi everybody. In this lesson we want to talk about simplifying some rational expressions. You remember that a rational expression is a ratio. Whenever in algebra and mathematics you hear rational, you should always think ratio. Ratio is like a fraction, right? A ratio of two polynomials. So this is an example of a rational expression. A polynomial in the numerator, another polynomial in the denominator. And the first thing that we want to look at is how you can simplify these rational expressions just like you simplify fractions. And remember, we can simplify fractions by canceling common factors. And the most important thing to remember when simplifying rational expressions that many students make a mistake on is that you can never, ever, never, absolutely ever, positively never, ever cancel terms. You can only cancel factors. Okay? So, as an example of the absolutely dead wrong way to cancel, if I have this rational expression, students sometimes will see these x squareds here and think that, oh, let's just go ahead and cancel those, or maybe this 2 and this 4, maybe we could cancel that. Okay? Well, that is absolutely dead wrong. You can't cancel that way. The correct way to cancel is to remember that you can only cancel factors, and so what you first need are some factors. So factor this expression. So if I write this as x plus 2 times x minus 2, so factor the numerator as the difference of squares, and then that denominator also factors as two binomials. I'm going to have an x and an x to get the x squared, and a 2 and a 1 will multiply to give me 2, and if I make these both plus, the outers and the inners from the FOIL method will give me the 3x in the middle. Alright, so now that I've factored it, now I see I have a common factor. Factors are things you multiply. Terms are things that you add and subtract. So over here, now I've got a factor of x plus 2 that I can go ahead and cancel, and that's going to give me x minus 2 over x plus 1. Okay? Alright, so that's the correct way to simplify a rational expression, is you want to factor it and then see if there's any common factors. Now, you can't just cancel terms. Alright, let me do one more little example of this. Here's a function, so it's the same sort of idea. I'm just expressing it in function form, and then we'd like to simplify this and then evaluate this function both at 2 and at negative 4. So notice that f of x, there's a common factor of 5 in the numerator, and go ahead and factor that out. And then there's a common factor of x in the denominator. I could go ahead and factor that out. And notice that we have a common factor, and I can go ahead and cancel that common factor. Alright? So when I do that, I get a new, more simplified form of this function, which would be just 5 over x. Okay? So notice that if I were to evaluate this function at 2, if I were to plug 2 up here, I would get, 5 times 2 plus 20 over 2 squared plus 4 times 2, and that gives me what I get. 10 plus 20, that's 30 in the top, and 2 squared is 4 plus 8, that's 12 on the bottom. And what you'll notice is there's a common factor of 6 between these, right? Because up here 2 plus 4 is 6, and that's represented right here. So I could write this as, not 30, 5 times 6 over 2 times 6, and then those 6's would cancel out, and that would give me 5 halves. And notice that would have been a lot easier, of course, to just plug 2 into this original, or the more simplified function up here. All right, so that's the same as just plugging into the simplified form, as we would expect. Okay? Alright, now there's something though. Notice that if I plug negative 4 if I were to just plug negative 4 in the simplified form, I'd get negative 5/4. So f of negative 4, I'm thinking, well, if I just plug it in here, I get negative 5/4. But notice if I plug it into my original problem here, 5 times negative 4 plus 20, and negative 4 squared plus 4 times negative 4, well, that's going to give me negative 20 plus 20, that's 0 on the top, and 16 minus 16, that's 0 on the bottom. Okay, so notice this isn't the same as when I plug it into the simplified form. So in fact, this isn't the same as when plugged into the simplified form. All right. So these can't be equal, right? What I said was this f of x right here that's equal to this. I put these equal signs, and notice that if I plug negative 4 into the original one, I get 0 over 0, and that is definitely not the same as when I plug negative 4 on this side. So these really can't be equal. And what's really wrong here, and the point of that I'm making, is that x plus 4 divided by x plus 4, it does cancel. It cancels for every single x in the whole wide world except for 1. See, notice if x is 2, when I plug 2 in here, I get 6 over 6, and 6 over 6 is 1, and that's what we mean when we cancel. I'm left with a factor of 1. And if x was, say, 12, if I plug in 12 to this up here, it's going to be the same as plugging in here, and I'd get, a common factor of 16, and that 16 would cancel. But when I plug in negative 4, I get 0 over 0, and 0 over 0 does not equal 1. In the same way, like 6 over 6 is 1, 16 over 16 is 1, but 0 over 0 does not equal 1. And so when you cancel these, I really need to make a little notation here that it's going to cancel for every value of x except x equals negative 4. And if I put that domain restriction, then this really is equal to this. So if I were to plug negative 4 now into the simplified form, I'd say, well, wait a minute, I can't plug negative 4 in because it makes it's undefined there, in the same way that I really can't plug negative 4 into this original problem because it makes division by 0. It's undefined. So in the same way, I just made it undefined right here. All right, so up here, if I come back to this previous problem, when I canceled those x plus 2's, I really should include that x cannot equal negative 2, because for every value of x, x plus 2 divided by x plus 2 will be 1, and they will cancel then. But if x was negative 2, then they wouldn't. 0 over 0 does not equal 1, it won't cancel. So I really want to extend my answer up here to be this. Okay?